Hello, my fellow YouTubers. This is Roy back again. Hopefully, the internet will allow us to have a few moments together. It would be nice. How you doing, Hassan? How you doing, Adam? My boys are on. So, interesting stuff tonight. Do you see this thing to your right? Right there? Guess what that is? What do you think that is, Adam? Yep. Vacuum tube. No, no vacuum tube is on. But yes, it is like a Van de Graaff without the capacity, without the top load. So I just put this together. I just pulled it out of the graveyard because it wasn't working for a while. So what I did was these things right here are, yes, static generator. You got it, Hassan. So these right here are steel cable that I cut and I made little points. Yeah, I don't know if you can see them on the very inside. What I did was I used this right here. I got it from Tractor Supply. It's a steel cable, insulated. I cut some points out of it and I made it as a pickup. And we'll talk about why we're using steel as a pickup. So basically the rubber band just spins. This is the negative side. Up here is the positive side. So I did 5 pieces, glued them together, and then I made points in the front, and I gave a little variance going on there. So let's go ahead and the reason I made this is because the last video I did was based on doing an LC circuit. And the LC circuit fascinated me because I'm starting to understand stuff a little bit different now. And as I look at energy in itself as a whole, I realized that these two pieces here, capacitor and inductor, were like a mirror image of each other, that they were out of phase. That when this one is charging, this one is decreasing itself. It's uncharging, and then vice versa. So when this was charging, this was decreasing. So they were flopping flippy. Okay, so I was fascinated by that, and I showed the last video with the lights and how it worked. And I said, well, what I'm showing myself with the video that I'm making to show you guys, I'm learning as I go to it as well, because this here would be your non-moving storage, which would be your high voltage static. Okay, this side here builds a magnetic field, which in that case stores energy. So it has to have a magnetic field to store. But this is in motion. So the energy on this side that we're looking at has to be in motion. The energy on this side, high voltage or whatever, it's non-motion. So here's your separation of powers that we have in our planet. It really is right there, right in front of our eyeballs. So I said to myself, well, I've done many videos on high voltage and the voltage that comes out of this into this capacitor I built. Got to be every bit of 400,000 volts. Every bit of it. It's amazing. So what I wanted to show you guys is a compilation of mixing high voltage into my array here of all my inductors, because this here I have. The funny thing is that these coils in the center. Let me get this out of here. These coils in the center are my pickup. They are one end, they're all connected in series, and one end is connected to the voltmeter and the other end is connected to the voltmeter, okay? It comes down as the other side of the voltmeter. So we're going to turn the voltmeter on. And let's just put it, let's go to DC. Let's put it at 200 DC. 200, why? Because I know it's going to be pushing some damn power. So what we have, the setup here, is we're coming out of the collector in the bottom. We're coming into the outside of the capacitor. This capacitor I had made a while back, but it's a special capacitor because it's a little different than this capacitor, because this capacitor is just one layer of foil, plastic, and one layer. This one, I increased it. I stepped it up a notch. What we have is foil on the inside, foil on the outside, and then insulated material, then another layer of foil with two connections. So we have a capacitance on top of a capacitance. Just some more capacitance buildup is what we have here. So the way I have this set up is out of the collectors, out of the top, one wire goes to the positive side of the inside of this capacitor. The also coming from the inside of this capacitor with the positive goes to my number one pin, which is connected to an array of my coils. Now remember this, the electric dragon is being juiced up right now in a different way. It's not being juiced up from my DC power supply. It's being juiced up. What does the... What's up, Mr. Willie? Got Master Willie in the house. Yo. So, Adam, what are the poles on what? On the static generator, the bottom is the negative. On the top is the positive. On the cap, this is the positive going in. This is the negative, okay? So we're coming out of the top, going into the positive side on the inside. We're coming out of there and going into one of the connections I have going to this whole array, okay? Not to the center, though. The center is just a pickup. The center is not connected to anything, and it goes just to the voltmeter. The secondary part, well, the outside of the capacitor, we'll say, has two levels. One's inside and one's on the outside. So these are insulating materials in between these two. One of these goes to the start of the, let me get you back there, to the start of the, sorry guys, I can't get you back there, but to the start of this coil array starts here, and the start starts down here. And what I'm doing is I'm sending a wave by itself, just like a positive and negative, how it goes towards each other in a spiral. That's what I'm doing here. This right here is fired up, and that's fired up at the same time with different resistance, and that's my resistance wire that goes up there. So we're just using this as the power supply. We're putting high voltage into here. We're backing that high voltage down into this array here, and we're getting some damn good voltage. So let's go ahead and let's do one test to show you guys. Let's disconnect the array here. We're going to disconnect all that. So here's the two disconnects, okay? Bam. Just those two are done. Let's go ahead and plug it in. Let's plug this puppy in. So we're going to get the rubber band moving. All right. Let's get the rubber band moving. Rubber band's moving. All right. So we got the rubber band moving. And right now the rubber band is just charging this one cap, okay? It's just the big capacitor. Now I wouldn't touch this because it ain't no damn joke, guys. Ain't no damn joke. Let's go ahead. I got my chicken stick here in my hand. I can already hear it snapping. Let's go ahead and check out what we're dealing with. What's up? We got Fred in the house. What's up, buddy? So we got this capacitor being filled by this rubber band Van de Graaff setup. No top load. The top load now is this capacitor. And we're going to go ahead and we're going to get, whoa, that was a snap, guys. That was a snap. Let's go ahead. And what I want to do now, I not only raise your hair, but hold on, guys. You guys got to see something. I just want to tell everybody, today's my birthday. So here you go. I got my birthday hat on. Turned 56 today. Proud. I lasted 56 years on this planet. Hopefully I can have some more time. Thank you, guys. Thank you. Hopefully you've seen my hat. This hat's been in my family now for 20 years. So every time somebody in my family, I got 4 kids, family of 6. So every time we have a family, somebody has to wear the hat. So let's go back to this guy again. Let's just check this. And I guess we don't need all the lights on, right? I can turn the lights down a little bit. Hold on. Let's see if we can get some good arcs going here. So one thing I want you to notice, I'm going to go ahead and turn the other light out. And I know you're going to see dark for right now, but notice can you see a flash? No, you can't. All right, let me put the lights back on. The capacitor is releasing a little bit within inside itself. So let's yeah, man, happy drinking. So let's go ahead and turn down some lights though. And let's check out this capacitor that has its own built-in release. It's like a spark gap going on. I don't know if you guys can see it. There you go. Watch the capacitor. See that spark, guys? Thanks, Willie. Guys, you guys see the spark there? I know you see that. Look to the right. Right about there. Look at that spark right there. See that? All right, so it's got its own little spark gap thing going. So now we're going to go ahead and we're going to release the energy because I need to hook up the other array. And let's look at what we're producing through the inductive part. Right now we're just dealing with the capacitance. But let's check out. Whoa, wait a minute now. That's crazy. Yeah, it is. The pretzel jar. All right. The breakdown of the materials. You see that spark? Is that unreal? All right, let's get this thing disconnected. Let me put the other light on. Let's get it disconnected and let's hook up. Let's hook up. All right, so we are officially unplugged. So right now I got this off, rubber bands off, and we got the capacitor just sitting here. So this is what we were talking about with the LC circuit, okay, guys? So with the LC circuit we were doing over here in my last video is the capacitor held the charge when it was by itself. When it's with the inductor, they swap the charges back and forth. So right now, let's check and see if we have charge holding there. We had this off for a little bit, right? Let's check it. Oh, yeah. So that's just a built up charge. Let's get it out of there again. All right, so a little charge there. Let's check this one as a secondary. Yep, that had charge too. So now I should be able to touch this. All right. This hurts when you hit it, and you know what? It's not even full. So now we're going to go ahead and we're going to connect all my coil array, okay? So this part here is getting connected to this run on this side is getting connected to this, and that's going to be the positive side. Now, remember what we're doing here. We're creating energy from the rubber band. We're storing the energy and building up into the capacitor, which is the capacitor side of an LC circuit would be what provides current, okay? And the inductor side is what provides the voltage. So now we're providing these inductors attached to this. Let's go ahead and get this son of a bitch going. Now I'm going to put you right here and look at the voltmeter. This voltmeter is hooked up on DC 200 volts. So the minute I plug this son of a bitch in, something should be popping up over there. Go ahead, find my cord, plug it in, fire in a hole. All right, let's see what's going on here. We have 35, 36 volts popping up. Okay, that's DC volts. We still have our spark. You can hear it. You hear it. You have your rubber band providing the energy to here. This is the new LC circuit we have going. We have massive amount of power being built up in the capacitance here from the rubber band. Thank God for rubber bands. Who says static means nothing? I don't understand this. I don't understand the static means nothing. It just, you have to know what to do with it. If you look at an LC circuit and you see half of the electricity is magnetic and the other half is electric, the electric is built up from static that's built up on the charges of this high capacitance. And basically right now we're sitting on what? 42 volts, 43 volts. Let's just see what AC has. I don't know if AC is going to show anything. There you go. AC is sitting there too. 36, 40 volts. So I don't know if the voltmeter, how accurate, but I'm going to dig into this. Because why? Because we're mixing the two energies, guys. You know, basically there's, in the world of energy, I mean, what do we have? We have kinetic and we have static. And basically the kinetic side is the inductor side, and the static is the other side. And the other side is non-moving, and the inductor side is the moving part. Here's your current, the capacitor. Here's your voltage, what's showing up on the voltmeter. Staying pretty steady. I got a little spark gap going. You see that right there, right? I don't want to touch that sucker. A little spark gap. And that's because on this capacitor, I built a double layer on the outside. The double layer on the outside is breaking through its dielectric. And that's allowing a built-in spark gap that's happening here, built up because this voltage is increasing heavily. Where's your comments, guys? I want to read some comments. You guys got anything to say? Leave your comments. Birthday boy's on a roll tonight. What's up, my buddy Jay? Well, you see it. You see what we're looking at. This ain't no joke. I don't want to make names, but, you know, I look at a lot of these people out there that says they got this, they got that. This is just common sense. I mean, it ain't common sense, but it is common sense. It's mixing the two energies. There's your static. There's your kinetic. It's crazy. Rubber band still moving. Still moving. Let's turn the rubber band off. Let's watch this thing drop. You ready? You got the voltage there. Rubber band going off. There, rubber band's off. So right now, I'm going to do a dummy test here. But I can tell you what, usually it won't be much of anything for spark here because it's been sucked up as a magnetic field in all these coils. There's a lot of coils out there. And basically, no, there's nothing. But meanwhile, if I disconnect the coils and they're not saturating Think about what's going on. Those coils are saturating this capacitor. Let's get this damn thing going again. So we're going to go ahead and we're going to plug in the cord. All right, we're going to plug in the cord. And let's get the rubber band thing going again. Okay, rubber band thing is wide open now. So right now we're just charging this capacitor. And think about this. This is energy with no Lenz's law applied at all. No Lenz's law at all. This is just high pressure, full. You can see it just charged because it just snapped over by itself. Full potential. I guess that's what I wanted to say earlier. The capacitor is the potential, and the coils are the inductor is the kinetic. So that's the two things you have as a common with energy. You got potential. Oh, if that don't kill you, that'll freaking hurt. Oh, that's massive amount of pressure in there. Now that pressure we're designing in here would be current. So we put that in the circuit and make a LC circuit here. We're gonna make current. So let's go ahead and we're gonna get one more snap over here. Get one more, let's release some of this energy. Oh yeah. Let's go ahead and, that was too much. I'm gonna have to release it one more time. Let's get a little bit more out of it. All right. Let's double check. I don't want to get snapped tonight. Oh yeah, I went too. All right, so here we go. So we're gonna connect. And now what we're doing, we're gonna take high pressure, high potential, let's call it, because that's what I'm calling high pressure, high potential. So high potential, and we're gonna mix it into the inductive field, and we're gonna make an LC circuit here. And what'll happen is when this is on its upstroke, this is on its downstroke. When this is on its downstroke, this is on its upstroke, meaning when this is charging, this is discharging. When this is charging, this is discharging. So, hey Jay, how's it going? My boy Jay. All right, so let's go ahead and plug in the rubber band. Let's go ahead and get that going. We've got the rubber band going. It's making some energy over here. It's charging up this capacitor, and it's interacting as an LC circuit with those coil array. And remember, these coils will be fired up first from this start and goes that way, and then simultaneously from that coil and goes that way. So we're creating a sine wave in between there. The coils in the middle are hooked up to nothing but the voltmeter. So right now we are looking at a good back again, guys. Same thing, nothing changes in the 30 to 40 volts DC. Right now we're sitting at 200 DC. So we got something going on here with mixing the high potential with the kinetic energy, and it doesn't need to be as they give it to us. We can make it ourselves. I know. Only a crazy guy like myself. Hey, funny thing is, the way I look at myself, guys, is that I'm a monkey that you put in a room with a bunch of computers. And I'm going to push every button until I figure out what's working, or the computers are going to blow up. So that's what you have here. And I tell you the truth, it's more fun being who I am and what I do and learning this stuff than it is being somebody who's been taught and only been taught one way and really just only thinks of it one way. And I feel bad for those peeps, because open your mind. There's many ways here. We talked about this. Did you guys see the video I made last night about Faraday? Anybody seen what I was talking about with Faraday? Faraday, self-taught. But what else about Faraday? Anybody knew what drove him to do what he actually accomplished? Electromagnetism. Does anybody hear about the story about Faraday and who actually gave him the drive and the incentive to do what he did? Funny thing, guys. Funny thing. I'm going to tell you a funny story. So here we go, guys. Back in 1820. How many years ago was 1820? $1820. How many years ago was that? No, Adam. 102 years ago? 1820? There you go. 100. That's boy Willie. 198 years ago. Well, let me tell you about this 198 years ago. 198 years ago, there was a dean. His name was Hans Christian Oversted. 1820, he accidentally observed the deflection of a magnetic needle in a current barren region. When our good friend Michael Faraday had come across this news, this writing, that this gentleman, Hans Christian Oversted, observed that electric and magnetism were connected in 1820. Michael Faraday wrote a note to himself, and the note that he wrote was this, and I find this to be fascinating. 198 years ago, when Michael Faraday heard that Oversted had observed the magnetic properties of electric current, namely the electricity produces magnetism, Faraday wrote in his notebook, "Make magnetism produce electricity." He wanted to reverse. If you're telling Michael Faraday that electricity made magnetism, he said, well, it should be, if that's true, you should be able to reverse it. So he left himself a note. Do you know it took Michael Faraday 11 years, 1831, do the math. It took 1831. It took Michael Faraday 11 years to produce electricity from magnetic currents. I hope you guys find that to be fascinating. Because look at us now, 198 years later. Look at the greats we have before us. They were just people like us, like all of us. All of us garage people, our physicists, our garage scientists, our garage readers, our novelists, people who just read and just know so much. Faraday took 11 years to make that happen on his notes. Think about the hardship all these greats had. Even Thomas Edison, he's quoted 1,100 times. He couldn't get the light bulb. He failed. Well, he's not a failure. It doesn't mean he failed. It just means that he just didn't have it right. With Mother Nature, this is Mother Nature. With Mother Nature, if you set up the right thing, Mother Nature will show you what you're looking for. So I hope you guys enjoy this video. You can see right now we've been staying steady at 35 to 40-something volts. Nothing has changed. The rubber band's still rolling. We'll go ahead and we'll do some studies. We'll see where this goes, because this all came out of really knowing more about the LC tank circuit. Well, Fred, I appreciate the comments. All you guys appreciate the comments. From a happy birthday boy, it's time to, let me see, what time is it? 11:25. I will put out diagrams. I got nothing to hide. Nothing to gain here. This is just all for the cause. Simple. Capacitor, homemade. Coils, homemade. Learning about the LC tank circuit was like awakening a sleeping giant with me. It's crazy what you have. I never really figured it out with all this stuff I've been doing 5 years, that high potential, meaning static is high potential. What does static go to? It goes to conductors. There's your two conductors. There's your non-moving storage. This here is electromagnetic. You have to have movement. This is your storage with movement. Once this is stopped supplying, the magnetic field collapse. Well, actually, before the magnetic field collapses on this L side of the circuit, the capacitor will release itself first. And then when it's released, you'll have the magnetic field. Then, only then, will it start to lose its magnetic strength. All right, you guys. Peace out, my brothers. Let's go ahead and get one more good snappy poo going here. Let's disconnect that. Let's disconnect that over there. And right now, we should have a good charge. I'm going to go ahead and turn the lights off. Do a good disconnect of this guy here. It's a little better with the lights off, though. This should be good on video. Let's see what we got. Oh, that is a crazy buildup. I don't know if you guys seen that. You had to see it. Peace out, my brothers. Guess it's better to see it. I don't know what you see in the dark. When I look back, I'll have to look. Oof. All right, Adam. You guys take care of my brothers. This is crazy the way I made these collectors. Really is. These collectors. I was kind of sure, though, because you can't use a conductor. You have to use iron. That's crazy, these collectors. And look, this thing's snapping. It's filled already. So it's, whoa. Let's go back to this. Look, I knocked off the rubber band, fell to the ground. All right, so it's gone. That's still turning, but nothing going on. And let's look and see what charge we have left still. All right. This is stored energy, non-moving, stored. You ain't getting that in an inductor. That's your high pressure there, guys. What's up, Brandon? All right, my boy. We're just getting ready to end the video. Check back with watch the video. It was a great video. Hope you guys enjoyed. Peace out, my brothers. Peace out, everybody.